Okay, so yeah, hi everyone. This is UTMIST's machine learning study group. Let me just go to the slide. Actually, I think since a few of you might be new, I'll just quickly go over what we do in this study group. So basically, we're trying to host an environment that allows us to go through together this Coursera course. So we started in the fall semester. So we already went through weeks 1 to 3, which was more focused on like basic neural networks and convolutional neural networks so that's for images. And then in this semester, we're looking to move to the later. We call it modules as well, since weeks might be a bit misleading. So oh, one thing is we're actually not following the Coursera schedule, since as you can see, like they go by weeks, but we go by months. So we will be on our 4th month, and so that's why this session we're focused on unsupervised learning. And then so yeah, this session will be focusing on the content and the concepts. And then next session, there's also labs. So we'll go over the labs in the next session. So that will be 1 month. And then in the next month, we'll be going over sequences. And then there's a final project at the end. Yeah. So I think this course is pretty fun, since it's like I've seen some other Coursera courses where it's more focused on the math and the concepts, but this one is actually more applied, which is pretty cool. So, and then there's also actually a project as well. Yeah, so this is what we have planned, and hopefully at the end, if we manage to get through everything, we can get a U of T sponsored certificate. Yay. Yeah, that would be nice. Yes, and then there's also I meant there's also a GitHub repo, so it has resources and the slides. Yeah, all these information you should be able to find them in the different channels on our server. So yeah, but feel free to let me know if you have any questions about how it works. Yeah. Yep. So now that you know more about what we do, we can get started on the content. So yeah, as I mentioned before, this session we're focusing on supervised learning. Yeah, so let's just get started. Yeah, okay. Sorry, just closing this tab. So the agenda for today will start off with an intro about what is unsupervised learning, although I think some of you might know already. We'll talk about auto-encoders, which is one type of how unsupervised learning is applied. And then we'll also talk about natural language processing, which is also an example of unsupervised learning. And then, of course, if we talk about natural language processing, we also gotta talk about word embeddings. So we'll go into more details later on today. Yeah, but this is the overall agenda of the concepts that we'll be going over today. Okay, so let's start off with what is unsupervised learning. Yeah, so if you could go on Slido and type in this ID, just to get our ideas flowing. Yeah, so what comes to mind when you think of unsupervised learning? Yeah. I'll give a few minutes for all of us to answer our ideas, and then we can see like what we think about it already. No given answers, right? Yeah. Yeah, I think that's a very good point. Yeah. Yeah, because in the previous sessions, we've when we try to look at data sets and then use those to solve the problems, usually there's you have the data and then you also have what some may call labels, I guess. So it's like the answer to the input. So for example, what's good? Oh yeah, again. So in the past few modules in the labs, we've used the UTMIST data set. So that will be like the different handwritten digits. So you have those images as inputs. And then you also have the corresponding labels for the answer, like whether that digit is a 0 or a 1 or an 8 or a 9, right? Yeah, so that was supervised learning. But now unsupervised, you don't know the answer. So yeah, that's essentially what it is. Yeah, so what is unsupervised learning? It's where you have the data, but you don't have the labels to the data. So as you can see, in this picture here, in your data you have apples and watermelons, but you don't know the answers to those data. So if you don't know the answer, then why do we still want to use it, right? So how is unsupervised learning useful, right? So first, unsupervised learning can extract the structure of the data, which can be pretty useful sometimes. Like in this example here, you're kind of doing some clustering, so you can cluster similar data together, so you can sort of distinguish that, okay, these apples look similar and these watermelons look similar. So you can like how it's mentioned here, like extract the structure of the data. And then also I think one of the reasons why it's pretty useful is the data that you gather is less costly, because like in machine learning especially, I think data is pretty important, and sometimes if you try to assign a label to each of the data you have, it can be pretty it takes a lot of effort, right? So now you don't have to have an answer to your data, so that's much easier. So in this case, the data would be easier to come by. Yeah. So that's a quick intro. Sorry, let me just admit someone. Yeah. Next is auto-encoders, which was also the next topic that was covered. So now we can see like how we can see more unsupervised learning in action. So auto-encoders, what it does, right? It's I pasted this image here. So what it does is it's able to, first of all, compress the input. So as you can see in this example here, you have, this is also an UTMIST example. So you have a handwritten 4, and then the encoder is able to compress it into this code. And then the decoder then reconstructs this code to form the output. So so that's essentially what it does. I'll go into more details in the next slide, but this is the overview of how an autoencoder works. So then again, like how is this useful, right? You just get a similar data. So I've listed them here. So first you can compress the data and then reduce its dimensions, which can be pretty helpful sometimes if you don't want. Sometimes, like if you have too large of a dimension, it might be hard to work with. So having it being compressed could be pretty useful. And then we also mentioned in the previous slides as well, you can learn the more important features And then in the last few sessions, we talked about supervised pre-training for CNNs, I believe. And then now you can also have unsupervised pre-training. So you can train it ahead of time, which saves effort. I feel like a lot of this, what we're trying to achieve is to save a lot of effort, right? So this could be how it can be useful. Okay, so it's architecture, just under more of understanding the deeper level of how it works under the surface. So basically, it's an artificial neural network. So it's a network of different neurons, as you can see here. And I think what makes it unique is that it's symmetrical, right? So when you're trying to encode, you're sort of reducing its dimensions. And then when you're trying to reconstruct it, you're increasing the dimensions once again to get the output. So it's a symmetric process. And then there are also different parameters that you can change. So this code that you have here, you can change the size of it. So then you can control its dimensions to like control how much you want it to be compressed. And then you can, of course, for any neural network, you can change the layers and the number of neurons per layer. So when you alter its architecture, you also change how it's learning and how it's being reconstructed. Yeah. So that's the architecture. It's very symmetrical. Okay, and then there are, so basically auto-encoders, it can get pretty trivial. Like if you're not training it in the right way, you would just like get a 4 and a 4, and that wouldn't be very useful. So you want to train it so that you can force it to learn the useful features, right? And I'm going to be going over 2 different types of auto-encoders that tries to achieve that goal, right? So one of them is the denoising auto-encoder. So for this one, you have the digit 4, but you add some noise into it. So here is the noisy input, and then you feed it into the auto-encoder. So you feed it into the encoder to turn into the code, and then the decoder will turn it into the output. So now, since you've added noise to the input, you can, by adding the noise to the input, the auto-encoder will, you're basically trying to force the auto-encoder to learn only the useful features, and then you can recover the original input. And then a different type is sparse auto-encoder. So this is basically kind of similar. You're using a regularization technique. This time, yeah, a regularization technique to force it to learn the useful features. So you can control, you can change the sparsity constraint. So how much of the nodes will be active at one point. So this is kind of similar to the regularization that we talked about in past sessions that prevents overfitting. So by doing this, you can also force the autoencoder to learn the key features. Okay, so that's it for the autoencoders. We'll talk about natural language processing next. So I also have a slide question here. This time it's, so what are some possible applications of, so NLP stands for natural language processing. I think, yeah, NLP is a pretty popular concept nowadays. Yeah, just before we dive deeper into this, like, have we seen this, or where have you seen this applied in real life already? Again, just gonna give it a few minutes, and then we can wait. Try to think about this. Yeah, voice assistants. Yeah, voice assistants are getting more and more popular these days. Right? Yep, voice assistants and then real-time video caption. Yeah. Grammarly, yeah, Grammarly. Yeah, I even use Grammarly here. Yeah. Yep, sentiment analysis. Right, trying to get what the person's feeling from their words. Yeah, these are all good examples. Yeah, it's so interesting how Grammarly is able to correct grammar that like humans might not even know sometimes. Yeah. Okay. Yeah, these are all really good ideas. So I've also put a few examples here. Well, first of all, natural language processing, what it is that it's trying to make machines understand the meaning behind words, right? I think what makes natural language processing different as well is for the other fields or areas, you might be like, let's say you're looking at numerical data or images. You can just use the data itself, but with languages, it's much more complex than that. So you have to understand not only like A, B, and C, you have to understand the meaning behind them. So that's what natural language processing is about. And this example here is, I think one of us mentioned this as well, sentiment analysis. So trying to get what the person's feeling just by their words. And then I think now it's getting more popular in the medical industry as well. Like there's a few papers about how machines can go through the online records, and then based on those records, they can make for example, diagnosis. And then this picture here is for, I'm sure we're probably more familiar. So now, like, finding recruitment, finding jobs, and then a lot of the job applications behind them, there might be machine learning behind that. So nowadays it might not be a human who's looking at your resume. And then this one is, so email filters. This one we're probably familiar with. Like sometimes they can go, well, sometimes it doesn't quite work. Like the good emails are getting to spam, but the spam emails are not getting into spam. But basically, at least it tries to go through the content and try to understand whether it's, or understand and classify whether it's a spam or not. Yeah, so as you can see, like it's very useful in real life. So how it works behind that, right? So like we mentioned, words, it's a bit hard. It's a different form of data. So and that's where word embeddings come into play. So you want to have a data representation of a word. If you just have like a very basic one, hot encoding, for example, so if you just say food is one, or like, sorry, that's not a good example. Apples is one, oranges is two. That's that's not a good representation since it doesn't relate to the meaning behind the word. So in word embeddings, you have, well, first it's a vector representation of a word, and then how it can store its meaning is that words with similar meaning are closer spatially. So in this example here, you can see the cities are closer together and food might be closer together. So that's how it stores the context or meaning of that word. Yeah, this is also like an example here, like Seattle and Boston, they're close. They have closer meaning, so they're placed closer spatially. So that's how word embeddings work, and that's how you try to represent words in a data format. Yeah, this is one example of a word embedding. So word2vec. It's a model that can be used to learn the embedding. And then there are also two types of it that I put here. So SIBO is okay, let's take a look at this example here. So the input you have, so the word is supposed to be, the sentence is supposed to be pineapples are spiky in yellow. But so in this one, you're trying to predict, oh, did I make a mistake here? Sorry. In this one, you're trying to predict the target word. I'm so sorry. This should be predicting the target word. So the context word, yeah, let's not look at what's on the left side. Let's just look at this image. The context words are the surrounding words, and then you have to, based on those context words, you have to predict the target word. So it should be spiky since it's higher probability that it fits here based on the word embedding. And then what's opposite of that is a skipgram. So you have the word, and then in this one, you're trying to predict the context or the surrounding word. And then how it's done is basically what we talked about in the previous slide here. Based on the meaning and how close they are, you can try to get a sense of which words have a higher probability to be placed there. Yeah, so this is pretty cool, I'd say. How they try to manipulate something so abstract and then turn it into data. Yeah. Yeah, so that's all I have prepared in terms of the concepts. So I just went over the concepts that was covered in this module. Now, yeah, there's time for us to discuss any maybe concepts that are harder to understand, or if you have any questions about some of the quizzes, we can, feel free to bring it up, type it in the chat or unmute, and then we can talk about them together.